So now that everyone has their, you have a playing card, you have a domino, you have a pens and pencils, and you have graph paper. For those of you who are online, you can either print off some 1 centimeter grid paper. If you Google that, it'll pop up, or you can just do it freehand. That's okay. It's just that's a little bit more precision. You'll kind of see what we're talking about. So what we're doing today is we are doing transformations. Right here. So transformations. This is the new topic that we're going to be going into. Now, this one's going to be a little bit different. We're not going to do a whole lot of workbook stuff today. We'll do a little bit, not a whole lot. And normally we do like exam style questions. You're not going to get those for this one. They exist out there. You're going to want to make sure you're using your practice time well, so that you are prepared for the exams with this stuff. But we are going to be doing a project this time, which I'll talk about maybe tomorrow. So we got transformations here. So transformations, you don't need to write this down. Don't worry, we'll deal with this later. So transformation is when you move a shape or an object from one location and you're transforming it to another. You're moving or rotating, you're manipulating a shape. You're manipulating an object. If I were to take a triangle and I were to rotate it, I have transformed it. So there's 4 primary things we can do. And I'll go, we're going to be going over what each of these things are. So there's 4 different types of transformations you can do. Nope, don't have to write this down. Nope. So when you move a shape or an object from one location to another, you're transforming it, and you can transform it 4 different ways. You can do just one of these at a time. You can do several of these at a time. We have translation, we have reflection, we have rotation, and we have dilation. So we're going to go into, so the main goal today is we're going to be looking in and exploring all 4 of these different things. So first off, we're going to talk about translation. Now, translation is, here we go, that's what I need. So translation is when you move an object horizontally or vertically, the shape doesn't change. So all I'm doing is I'm taking any type of an object and I'm just moving it. That's what it is. So only the location changes. So to give you an idea what that looks like here, in terms of like a math problem, something like this. What happened in this case was there was this shape here that was translated. It was moved horizontally 2 to the right. So when you're translating something, you're just taking a shape and you're moving it. It's the exact same shape, right? It's the same length, width, same size. It's not rotated. It was just moved. So what you're going to do is you're going to need your domino. You're going to need your domino. And you're going to need a grid paper. And so what I want you to do is, I want you to take your domino, just lay it kind of like flat, like how you can see there. It can be any way you want. You could have it going like up and down or left and right. It doesn't really matter. But I just want you to take your domino and I want you to really quickly sketch it onto that graph paper, about as good as you can. You want to make sure you're going into the lines here. So like if maybe your dominoes only goes up to like halfway across the line, just extend it out. We're not trying to be exact here. We're just trying to make this easy on ourselves. So you want to actually draw your domino on there. And I will give you a couple seconds for that. So once you've sketched your domino, what you're going to do is you're going to translate. So when it says it wants you to translate it 3 to the right, and this would also be saying, if we're moving it to the right, we're moving it along this line here, right? I know that's a very hard line to see. That's our x-axis, right? So what this is actually saying is we want to move it 3 plus on the x-axis. It's being moved 3 times on the x-axis, right? It's positive. So that we don't actually write this little plus here. This is just a positive 3, right? So if I'm moving this 3 times along the x-axis, to literally take your domino, put it over top of your drawing, and just move it 3 lines to the right. So that's what I wanted to talk about here. So don't draw anything yet, but you're right. There's an overlap, right? You're going to have yours is not going to look like this. So what I've done here is I've done a common error with translating it. So what I've done is I've started at one point. Usually you pick like the bottom left corner, for example. That's what I'm drawing this little circle for. You move it 3 to the right. You would then start your domino how you see it here, right? So I draw my 6s, my lines. So if you're doing this correctly, you would have an overlap. Now, we're not going to actually have an overlap here. What I'm going to do is let me erase all this stuff. I'll erase all the ink on slide. What I want you to actually do is I want you to now, sorry? Yeah, you just kind of like jumping 3 to the right. Yeah, but what I want you to actually do now is I want you to translate it so that there's three of these little rows, 3 of these grids between them. Yeah, and I don't actually know how long, how far that would be. You don't have to. You don't have to draw it in this case. No, you will end up drawing that. You will end up drawing on that a little bit later. But when you moved your domino, did you guys move it 7 times to the right from when you had it overlapped to when you started moving it? If I'm correct, you should have moved it 7 times if you had your domino laying flat like that. Yeah. So what you've actually done is, so this is not, oh, I've moved it 3 to the right along the x-axis. No. You have moved it 7 times along the x-axis, right? That's what you've actually done here. So you haven't moved it 3 times, you've moved it 7 times. So that's just a common mistake people make. Oh, if I move it 3 to the right, I'm going to have 3 spaces. Nope, there will be overlap if your object's too big, right? If it was a really small domino, you wouldn't have overlap, but we did have overlap in this case. So what I'm going to do here is I'm going to, here we go. So don't actually do this. It says 3 to the right and 6 down. It says 3 to the right and 6 down. What I want you to actually do is make sure that there is, same thing, make sure there's a gap to the right. That's 3, and make sure there's a gap down, that's 6. So you should have 6 centimeters of white space going down, up and down, 3 centimeters of white space going to the left and right. Again, how you see it on this screen is the incorrect way.
So it's not supposed to be 4 spaces between that and one, it's supposed to be 6.
So now if you're going up and down, now it should be 6 spaces, yes, yeah. I think your domino is about 2 centimeters tall. So what should have happened here is you should have moved that up and down, not 6 times. You should have moved that 8 down, right? So that domino should have been moved a total of 8 centimeters down, 8 of those grids down in order to get that gap there. And then this to the right is the exact same thing. You had to move that a total of centimeters 4 long. You're moving it 3 to the right. You've had to move it a total of 7 centimeters to the right. So that's what translated is. Translated is just moving it. You can move it to the left and right horizontally. You can move it up and down vertically. You can do both in one. So what this is, we've done 2 translations in one. This is a multiple step transformation. So what we're going to do now is we're going to do a reflection. Now, for those of you who are here, I actually have something I'm going to show you. That's what that little like stand I have on that table for is with the red thing. For those of you online, I'm just going to ask you to bear with me for a couple of minutes. So when you reflect something, so those of you here, you see that red thing I have there? That's what we call a reflection line. So reflections when you create a mirror image. In this case, the reflection line is this red line here I'm drawn. So this is where the image is reflected. For those of you who looked at the red thing there, the red thing itself is the reflection line. So it creates a copy, creates a mirror image at that point onwards. If I were to place that domino further away from that red thing, it would appear further away on the reflection, for example. So we have this thing here. So when you create a mirror image, this is the line here. It goes by different names depending on like which curriculum you look at. But usually it's a line of reflection or a reflection line or a mirror line. It's the line the stuff is mirrored off of. So in this case here, this triangle that you see here was mirrored 2 centimeters away on both sides. So that means this mirrored thing here, this pink shape, has to be 2 centimeters away from that line then as well. Now you can have a reflection line however the heck you want. You can have it going horizontally, that's just a flat line. You can have it going vertically, that's a line that goes straight up and down, or you can have it reflected diagonally as well. Now you're not going to have to do too much diagonal stuff, especially with the draw-in component of it. Sometimes you're eventually going to have to look at and find some reflection lines a little bit later here, but just to give a really, really quick summary here, when you are reflecting something, you can go vertical, horizontal, diagonal, and it's all along those lines that happen there, right? That's your reflection line, your line of reflection, your mirror line. There's a ton of different words for it. It's the line it's reflected off of. So what you're going to do is, I want you to take your domino, and I want you to reflect it 6 down. So what your line's going to be is actually right here. It's going to be right in between those six lines. On another piece of paper. Yes. Yeah. So I want you to take a new piece of graph paper, really quickly sketch in your domino. And then you're going to draw a line of reflection 3 tiles away, right? It's a 3 tile away line here. I don't know why this is here. This shouldn't be here. That was me not deleting stuff because I was lazy, apparently. Cool. So everyone has that sketch then. So if you've reflected your domino, it should look something like this. Now, pay particular note to the odd things that happen there, specifically like the 3 here, right? It should be going a different way. Your domino should not be an exact copy of paste. It should be a true reflection. So how you actually are going to reflect something here. Come on. So how you actually reflect something here. Where? Why are you not? There we go. So I'm going to use black ink. Sure. Okay, I'm going to use a black ink here. So what I'm going to do here, so first off, we have ourselves our line of reflection here, right? That's that black line that you see on your screen. So what's actually happening here is you're taking all the points of your shape. So I'm using all 4 points, the 4 corners of it. I'm just going to go A, B, C, and D. Just label them. So what you're actually doing here is, so first off, how far away is C from that line of reflection? From the line. So C is 3 away from the line, right? So when you reflect it, C right here should also be 3 away from that line. So you're gonna notice this little symbol here. You'll see this in like a not freehand on PowerPoint version, but that's called prime. So you see how we have shape C on the very, very top, on the top part, and then on the bottom we have C prime. That just shows that, hey, this is that point just reflected. And then same thing down here would be line B, D prime. Over here would be A prime. And then up here on this top left of our new shape would be D prime. You look at how far away something is from this line of reflection, and then that's how far away it needs to be when you go to the mirrored image. So in this case, I can see that B for my image here is 1, 2, 3, 4, 5, 6, 7. It's 8 away. So then that means that my B on my shape here, my reflected image down here, also needs to be 8 away. Now for you guys, I think it should be a total of 5, just because your domino's 2 centimeters by 4 centimeters. Is yours 6?
Over that? Okay.
Yeah.
Mine's 5.
Okay.
Thanks.
Oh yeah. No. So just between like point and point. So yeah. So you're looking at how far away they are there. Now, so first off, I'm not going to make you guys draw this. I just want you to pay attention to here. Why is this one incorrect? Why I've done what I've done here.
3 is the same way.
The 3 is the same way, right? That's absolutely right. The 3 is the exact same way. This point right here, this 3 point, let me change my ink color. I'm going to make this red.
I got a easy one. I got a
You got a 5 and 1. Yeah, some of them are a little bit easier. The whole point of this is just to explore around with it. We'll more formally learn it in a bit, but again, thinking about it, like how come they need to be different? How come these need to be different? Your domino should look like what I have on the red side stuff here on the very, very top right. Because if I take this line here, if I take that very top point of my 3, I can see it's 1, 2, 3, 4, 5. It's 6 away from my line of reflection, which means it then needs to be 6 away from our line of reflection. But if you've done it exactly like how you see here, oh, well, it's only 3 away. It's wrong. It doesn't work. So that's a really common error that you see. You might be asked to actually point out this specific arrow or error in your departmental, for example. You might see some type of diagonal that looks weird, and they're going to ask you what's wrong with this. I've seen that question before, but just to give you an idea there. So this is the correct version, right? Because all these points here on our shape are now the equal distance away from this line of reflection. So that's a really common error students make, is they will reflect it, but they won't do those really small details correct. They'll do the corners correct, but if there's any stuff inside, it doesn't work out very well. So what I'm going to give you guys like 3 or 4 minutes to do here is on a new sheet of paper. Everyone has 3 sheets, right? You'll need a 4th. Yeah, okay. If you're coming up to grab more, grab 2 extra. You'll probably want a 4th one later. And there should be enough there. I think no, there isn't. Let me. I have more. Everyone needs 4 sheets in total. Do not run. Go. And you're gonna okay. We've only done 2 of these 4. We've done, let me scroll up. We've done translation. We've learned to move stuff. You can move it left and right, horizontally. You can move it up and down, vertically. And we've learned reflection, which is where you mirror the image. But if you remember, there's a total of 4 things that we've learned here. There's rotation. We're going to use our computers for this one in a bit. And then there's something called dilation. You've done this before. You just don't know that you have. I might do it. I might not. We're going to see how it goes. But I want you to really quick. I just want us to focus on these top 2 for right now. Once we're done with this next task, we're going to be going to a website and playing around with it in a second. But what I want you to do is on your new 3rd sheet of paper. Oops. No. On your 3rd sheet of paper, I want you to this is what your card's going to be now. So you're going to have your card. I want you to take your card. You can orient it any way you want. You can have it where it's taller or wider, up to you. And I want you to reflect it. I want you to reflect it horizontally by 4 centimeters. That means your playing card. Yeah. Yeah. So I want you to reflect it horizontally by 4 centimeters. I'm going to come take a look at it in like 30 seconds, see how we're doing. But what that means is, horizontally is to the left and right, but your line of reflection is going to be no verticals up and down. Yeah. So you want to reflect it horizontally by 4 centimeters. That means your line of reflection, that mirrored line, is 4 centimeters away from the card. So that line is 4 centimeters away from that card. And then I also want you to on your sheet is I also want you to translate that card. Not 6 centimeters down into left. Let me change those numbers. Let me do. Let me change that. And
so 4 centimeters down would be like 2 centimeters, right?
I'm actually changing those numbers. So first off, you're reflecting horizontally by 4 centimeters, and then you're also going to take that and you're going to translate it. So you're going to 12 centimeters on the x-axis. It's a positive 12, right? Pay attention to the details. That means it's moving to the right. And then it's negative 8 centimeters on the y-axis. That means it's moving down. Now, I don't want you to do 2 separate drawings. You are taking this card and you are applying both of these to it It is both of these happening at once. And I'm gonna come check and see how we're doing in a minute. Resume recording. Well, people who are online are just gonna have to miss that part. So when you've taken your card and you've reflected and then translated it, so first off, you've reflected it, the 4 centimeters here, but now you have to translate it. And then when it talks about this plus 12 centimeters here, on the x-axis, what that means is it's going to the right by 12 centimeters. But it's not that there's going to be a big gap of 12 centimeters. Remember, you start, everything's just going to be 12 centimeters to the right. So you start on this left corner and you count this. So it's 1, 2, 3, 4, 5, 6, and then it's going to be 6 more. There's only going to be a 6 centimeter gap between those two cards, for example. In this case, for yours, it might be more than 6. I just took a picture off the internet. I don't think that's the scale accurately. I don't know how wide your guys' cards are, but there's going to be a small gap. If you have a really, really huge gap, you probably made that common error, and that's okay. We're just kind of like playing around with this stuff right now. And then you also want to move it minus 8 centimeters on the y-axis. So same thing, you have to include this stuff on here. So minus 8 centimeters means that, okay, you start at a corner, count it. So 1, 2, 3, 4, 5, 6, 7, 8. You would actually then start drawing it in this case, exactly like how you see it here. Now you wouldn't have an overlap. I made sure that you would not get that overlap. But same thing, you have to actually factor in the shape itself when you're translating that. You have to, if your translation is too small, if I said move it 1 centimeter to the right and 1 centimeter down, it would basically be completely overlapped, other than a tiny little part of the card. So maybe your thing kind of looks like this in this case. Moves it's a little bit to the right, a little bit down, for example. If you factored in the actual shape of your card into it, you start on that top left corner and then start counting. It'll be a lot closer. You should not have a huge gap. I can come take a look if you're interested, but the whole point of this was we were just going to play around with it. Now, there's one reflection we haven't talked about. You're not going to have to draw anything for this. That's okay. Just want to really quickly touch over that. So we have reflections here. You can do it diagonally as well. Now, in this specific case, all you need to think about when you're doing it diagonally, because this is something a lot of people struggle with, is same thing. Just start at a point, think about how far it is away from the line. In this case, it's about half a centimeter away from the line. I'm going to go another half centimeter, and then that's going to be your starting point, right? Same thing over here. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters away from the line. So you just count out 9 centimeters here. There's your top. This one over here is 1 centimeter away. So you'd make this 1 centimeter away. All of a sudden you'd have yourself your shape here. I know my lines here are kind of in the way, but reflections on a diagonal are hard. We'll get more opportunity to practice that. I just didn't want to have to make you guys draw that. We'll practice that in a bit, but just wanted to show you an example of that. So what we're going to do is we're going to take a step away from that. So we are going to do some workbook stuff now. We're going to start going into those 2 new topics we haven't looked into. I'm going to give you a spoiler. Tomorrow we will be doing some painting. So just be really careful. Not finger painting. I hope not finger painting. But we will be working with paint on some stuff. We're gonna be starting our project tomorrow. So just be a little wary of your clothes. Just be careful. I think the stuff I have is waterproof. I can't guarantee it. So just be careful tomorrow. Okay. So maybe if you're looking at your outfits, you're like, I'm gonna wear this all white suit I have. Maybe don't do that. But you shouldn't get any paint or anything on you. But I just want to say that now before I forget. Maybe just put a little reflection into what you might wear tomorrow, just in case an accident happens. As long as you're not like face planting yourself in the paint, you should be okay. But I just don't want to have to get to that problem in the first place. Here we go. So I'm just going to start handing these out. We're not going to spend too long on it for this first part. I just want to go through some little thoughts. That and that. Oh. Hello, are you for the skills program?
Yeah.
You'll be in that one. Yeah, yeah, perfect. Sorry? So I'm actually not your instructor. Your instructor's in those doors.
Oh.
She'll be thrilled to see you though. The wood ones. Yeah. Here we go. So what you guys now have is you have your workbook here. Let me zoom in. So transformations, right? There's going to be a couple things I'm going to want you to box with this. We know what a transformation is. A transformation is just moving a shape. You're changing something to it, rotating it, making it bigger, whatever. So we have our four things here. We have translations. So we know translations is you're moving an object horizontally or vertically. The only thing that changes the location. That's exactly what we've just done. We know what a reflection is. That's when you create a mirror image. And as a reminder here, you can see that the tip of this triangle, let me make this red. The tip of this triangle is one line away from this reflection line here. That's what this is. So I can see the tip of my triangle is 1 centimeter away from this reflection line, which means that the tip of my reflected triangle needs to be 1 centimeter away from it. These lines right here are 3 centimeters away, which means this one needs to be 3 centimeters away. So again, just a quick recap of some stuff that we've done. Now there's two other ones, and we're going to play around with the website for this. There's rotation. Rotation's where you rotate an object around a fixed point. In this case, every fixed point you guys are going to do, and I want you to draw this in here, is this. Now we know where that is on a coordinate plane. It's 0, 0, right? Now what this is technically called is, it's the origin, which is 0, 0, right? We've played around with that before a lot, but most of the things you're going to rotate are you're going to rotate around that origin. And then the other thing as well is going to be, we have something called dilation. So rotation is rotating an object. We're going to play around on a computer for that. That's another one that tends to be a little bit more of a mind buster. That and reflection tend to be the hardest ones for people, just because our minds don't work that well that way. And then there's dilation. Dilation is you're making it bigger or you're making it smaller. So for example, if let's say, for example, the length of this thing here was, I don't know, let's say it's 2. And now and the big one's 4. The dilation here was, it was a 2 times enlargement, right? Again, we'll properly explore this, but I just wanted to give us a quick introduction to those last two things. So we have translation, moving it. We have reflection, that's reflecting it. We have rotation, you're rotating it, and then we have dilation, that's making it bigger or smaller. Okay. So what I'm going to get everyone to go to here, you're going to need your computer for this if you don't have it out yet. So everyone's going to need their computer. Here we go. Let me put this in the LMS. Oh. Cool. So when you're on your computer here, I'm going to get you to head to the Math LMS. So head to your Math LMS, the Workplace and Apprenticeship 30. And on there, you should find on Unit 6 transformations, there's a link. So head to the LMS, go to Math, go to Unit 6, and go to the link. Yeah, GeoGebra. So we're not going to go through all this stuff here, but we're specifically going to be focused on rotations. So what I'm going to want you to do is I just want you to click on this thing down below. So if you click on this, it's going to make it a little bit bigger, and you can actually play around with it. Oh, it didn't make it bigger. But what they have here is, what they've done here is they just have a translation that's happened here. So if you look on this little arrow here, can I make this bigger? Here we go. If you look on this little arrow down here, this is how it's being moved, right? So you can play around with this if you want. You can make it really, really short. You notice there's an overlap. You can make it really far so that there is no overlap. You can make it nice, clean numbers. In this case, I'm going to go up by 2 and to the right by 2. So I've translated it 2 units up and 2 units to the right. Cool. But you could also make it like, you know, look, there's like decimals in there now, 1.45 and 1.6. You could do that too, but either way, this just gives you a good idea of translation. Now, if you go down, so you're moving this arrow here, you go down, you can go into the negatives here, right? So you're using all 4 planes of this coordinates here. So sometimes it's positive, sometimes it's negative. Eventually, we're going to start labeling these points. So I'm just going to move mine up here so that it's 2 and 2. Goes 2 up, goes 2 to the right. If you look on the left side, I know it's very hard to see on my screen, but if you look on the left side, you're going to see these boxes for A, B, and C, right? So what we're eventually going to start having to do is we're going to eventually start having to label our points. So you can see that my triangle here has point A, point B, point C, and each one of those points is just being transcribed or translated up to and to the right to. And so they have new coordinates here. And if I'm not going to make you draw these, no. I just wanted to give you an idea here. So first off, you're not going to be able to see it. You just can't. But this little purple A here to the right, that's called A prime. It's the A point of our new shape. A got moved there. So I just want to do a really quick summary again of that translation there. So what we're going to do now is we're going to go into rotation. So I want you to go on this left side and you'll find rotating image and just click that. So what this is literally you can just move this little dial here and you can move it around however you want. Now you see what's actually happening here is when you rotate this, let's say you rotate this 90 degrees. If you rotate this 90 degrees, what you're doing here is you are not rotating the picture. You're not rotating from the corner of this picture, this bottom left corner. You're rotating from the origin, right? It's that 0, 0 point. That's what's being rotated around. Everything's going to get rotated around that 0, 0 point. That's called the origin. So I don't have a little like way to draw anything in here. Can I make this full screen? Yeah. I don't have a way to draw in here, but if you were to take this line, so if you look at where my mouse is to the 0, to the origin here, this is the same distance. So from the bottom left point of my original image to the origin, let's say that's, I don't know, 2 centimeters or something. That's the same distance as it is from that bottom left corner of this one here, right? That's what got rotated. So we'll go a little bit more into it, but that's what a rotation is. And of course, you can only rotate 360 degrees, right? That's all you can do. So we're gonna go to the next section here, investigating rotations. So I'm just going to give you a minute, and I just want you to think about what happens to your points as you rotate it. So what happens to your points? And you can see your points at this thing here. These left things, you have A, you have A prime, you have B, you have B prime. Can I make this? I want to be full screen. How do I be full screen? There we go. So as you rotate this, you notice in these A prime and B prime and C prime, that's your rotated shape are changing. Just going to give you a minute. I just want you to think about there's a rule that's happening here. You're not going to be expected to memorize it, but I just want you to investigate it. So give this a rotation, give you 1 minute. Just think about what's happening to those happening. What's happening to our points of our new shape, of our prime number. They're changing, but how are they changing? Are like the numbers changing? Is the positive, negative changing? Any guesses?
And one, two, just all numbers.
Yeah, it all mirrors. So you're not going to get any new numbers introduced. Whatever your coordinates are of your original shape, those are going to be the same numbers used in the next coordinates. Now they might be different. Like if I look at, for example, B, and then I look at B prime after a 90-degree rotation, it's 2 and 4 versus, well, yeah, so it's 2 and 4 originally, and then it goes to -4 and 2. So sometimes it's just reversed and the signs change a little bit. So if you're looking at this, you're like, okay, it's 2 and 4, and you come up with a 5, or you come up with like maybe like a 7, you come up with a number that's not in your original shape, you've done something wrong in your rotation. So you should always be having the same original numbers. They're just going to be ordered a little bit different. We're almost done on the rotations here. Come on.
What's that now? Rotation?
Yeah, this one's rotations, but I don't actually think I want to do anything with this, to be honest with you.
The coverage. Well, or maybe crown together.
Oh, a crown together. Yeah, kind of. You know what? Yeah, we're gonna skip this section here. That's okay. We're just gonna skip this one. We don't need to do too much with this one. So we're actually done with GeoGebra for now. We might be exploring a little bit later, but for now we can just kind of close out of that. It was just, again, an idea to be able to like look at some of the stuff without having to draw a bunch of shapes. So we're just gonna head back to our workbook here. So the one thing I really want us to start focusing on now is, I think we have a decent idea about how to do some of this stuff, but what we're kind of missing is the coordinates part of it, the more mathy component of it. So
are these the drawings?
some of these,
Yeah.
yes, yeah. Some of them you're gonna have to draw. So for example, if we go into example 1 here, if I go into example 1 here, it wants me to translate this 6 units to the right and 2 units down. So we know translation just means moving up, down, left, and right, right? So I'm just going to really quickly do that. You guys have an idea, but I want us to label the coordinates.
The house. Like, you start from A to right? Backwards from mountain 6. And then you put it. That's my understanding.
So yeah, so my recommendation is start on any corner. You could start, well, why don't we do it? Sure. Let's, you know what, I'm gonna pick C just because bottom left corner. And start with like a nice squared object. So if I'm moving it 2 units to the right, start at C and you count that, right? So it's 1, 2, 3, 4, 5, and 6 kind of end up right here, but it's also 2 units down. So what I have that point here, so this is C prime, and I'm actually going to label that in my diagram. So C prime should be exactly where you see on your screen there. And then what I'm going to do is, now I'll give you a hint. You don't need to do these lines. You don't need to count that distance from every single point. You can just look at your original shape now, and you can just kind of do some really quick like math. I can see that, oh, if I go 3 up, I end up at B. So if I go 3 up, I'm now at my B prime. And then, oh, 2 diagonal is my A, so that's now my A prime. 2 more diagonal is my E prime. And if you connect these two, you're going to end up with D prime. So you should have a shape that looks like this with those exact coordinates. Yeah, there we go. So this is what it's going to look like. Now, it wants us to know the coordinates of these vertices. That's the fancy way of saying is where's the points, right? So what I would, if it's asking you that, what you simply put is, oh, well, I know that A prime is 1, 2, 3. It's 4. It's 4 on my x-axis.
We have to name all of those?
Yes, yeah.
The opposites, 9 and 11.
So exactly how you see it on here is what your image should now look like. And I've labeled everything there. So if you want to know the coordinates of A prime, I can see that it's 4 along the x-axis and it's on 0 on my y-axis. So it would just be a positive 4 and 0, right? For B prime, my B prime in this case is it's 2 to the right and it's down 2. So it goes 2 to the positive on my x and it goes down 2 on my y, so -2. So it's +2, -2 would be my coordinates there. For C prime, that's that bottom left corner here. I can see it's 2, that's +2 on my x-axis. And it's down 1, 2, 3, 4. It's down 5. So 2 and -5. D prime, same thing. It's going to be -1, 2, 3, 4, 5, 6, -6, or sorry, +6 on my x-axis, -5 on my y. And E prime. So prime's just that little tiny line that goes through them, right? Little tiny line above it. That one's just 6, -2. So you've drawn it and you've labeled it. You've labeled your new points on it. Okay. Yeah, just an example there of translation again. The main thing I want us to focus on now as we're doing this is the points. So the main thing is the points here that are associated. So we have to understand like how to properly place that stuff and then how to label each of them. So it's not just being able to draw it, it's also being able to label it is a really key component of this. Yeah. So again, this is what it looks like right here. we're not going to worry about this one. You can come back to this later. We've done a lot of translation practice for now. You can come back to this later. I want us to go on to our next two things, which are dilation, making stuff bigger and smaller, and rotation. So to do that, we're going to just kind of scroll on our way to. We're going to go down quite a couple bit of pages here. Come on. Oh my gosh, it's quite a bit. Yeah, here we go. We're going to go down to page 230. So quite a bit. You know what? Before we do that, actually, I just want to get an idea how everyone's feeling with this. So just kind of like a three-finger policy here. Three fingers if you're like, yep, I know everything about this. I'm confident with translations. I'm confident with reflections. Two, if you're like, I think I got it. And one, if you're like, I don't feel confident. Just want to get an understanding where everyone's at. I don't want to move too fast. How you feeling with it, Kim? Everyone else is given 3, so I think we'll keep going then. We'll go straight to rotations. Okay, so we know what a rotation is. Rotations, when those objects are rotated around a fixed point, that's the origin, that's that center, that's that little red point here I'm drawing right now.
So it's just the mirror at the bottom.
Kinda, yeah, kinda. Let me get to my notes here. Sorry, a lot of pages forward. So first off, for this example we're going to be doing, you can find the mirrored stuff on the next page. I'm just going to ask, try to refrain from looking at it, but if in case you're worried about, I might draw it wrong, there is this is what it should look like example on the next page. So don't worry too much about that one here. Ow. So what's going to happen here is, so first off, for our first 90 degrees. So for our first, that's not percentage. So there's some rules here that kind of follow. So when we were playing around with GeoGebra, there's a rule here that kind of happens here. So first off, what we're going to be doing is we're going to be rotating this. It wants us to rotate this clockwise. Clockwise, right? The way a clock goes, clockwise goes like this, right? So I want you to rotate this clockwise. So first, so what you're imagining here is imagine you're cutting this out and kind of like placing this after you rotate it. But what's going to happen with these first 90 degrees is, so first off, all of our X coordinates, it's on this half of the, I'm just going to color it in. So we're going, come on, there we go. So we're going clockwise, right? So it's going to end up in this yellow thing that we're doing here. So first off, all of our X's are going to be positive. So I'm just going to put a plus X there, right? All of the X's are going to be positive, and all of the Y's are going to be negative for every single point that you make, because you want to state the coordinates. That's the main thing we're focusing on now. Not just being able to do it, but being able to do the coordinates. So when you're rotating it, it's almost like a mirrored reflection. So if I'm rotating this here, my A is going to stay the exact same. So in this case, my B is being rotated 90 degrees. So my B goes from a, what is that? That's a 1 and a +3. So in this case, your B is going to end up right here. It's going to end up on a +3 and a -1. So this point right here is going to be B. Your C in this case is going to end up, if you rotate this, what is that? That's 4 up and 4 to the right. That'll be the same thing. So 1, 2, 3, 4, and 4. So +4, -4. That is point C. And then point D is 3 to the right, 1 up. So now it's going to be 3 to the down and 1 to the right. The point D. So your shape should look something like this. So here's kind of the rule that's going to happen here. And you're going to want to actually write this down. In fact, you're probably going to want to write it down up on your reflection here. Oops. But so when you rotate 90 degrees clockwise, here's a rule that's going to happen. So did anyone struggle like rotating that? Just drawing the lines. Okay, most students actually kind of struggle with rotating it, because how did B get all the way down here, for example? How did D end up all the way down here? So a lot of students tend to like struggle with that. You know what? If it comes naturally to you, great. If you're unsure though, there is a rule. So when you rotate something 90 degrees clockwise, what's going to happen is the X coordinates. Come on. The X coordinates are going to change their sign. Oh, sorry. The X coordinates and the Y coordinates switch position. And one of the signs change. So coordinates switch position. So instead of 1, 3, it's now 3 and 1. So for point B, instead of 1, 3, it's 3 and 1. And then one of those signs is going to change. That's just where you need to think about which quadrant is it in. That's where you just need to kind of like, I highlighted that to give you an idea there. And so then that exact same rule is going to apply as you keep rotating it, right? So as I keep rotating this, you just repeat that exact same rule. So when you rotate it 180 degrees, they switch position once and then they switch position again. So to give you an idea there, so I'm going to follow the path of point B. I'm going to use blue for this. So point B starts as 1 and 3. And then it eventually moves to 3 and -1. So if I'm rotating it another 90 degrees, what happens with those two coordinates, the X and Y coordinates, according to that rule? They switch. Yeah. So now instead of going 3 and 1, it's going to be 1 and 3. So if I'm rotating it again, it's going to be in this blue highlight. Actually, I'm not going to highlight that blue. It's going to be in this next quadrant down here. So now it's going to be same thing, 1 and 3, but specifically, okay, these are all negative Y's and negative X's. So right here, so it's going to end up right here. This is where my B is going to be again. So this case is going to be a -1 and a -3. Those two coordinates changed. Instead of 3 and 1, it's now 1 and 3. And then you just have to use logic with the signs, okay? So the same is going to hold true for C. So instead of 4 and 4, it's going to be, well, you flip those around, it's going to be 4 and 4. That's C. And then for D, so D in this case was 1 and 3. Now it's going to be 3 and 1. And A, of course, is stay the same because it's on that 0, 0. So as long as you remember that rule for every 90 degrees, your X and Y coordinates switch, and then you just have to use logic with the signs. Oh, yes, yes. Okay, I'll zoom out a little bit. Is that big enough? Yeah. So again, if first off, if you're able to rotate it really naturally, personally, I'm a guy who struggles with rotating it. Like that was something I always struggled with, was just being able to map that out. This is the rule with it. Every 90 degrees you rotate clockwise. That clockwise is really important. Your degrees, your X and Y coordinates switch, and then you just have to use logic with your signs. Okay. So I will give you a minute here to finish up this last quadrant. And if you want to check your work, you can just go down one more page and you'll find the completed solution there. So I'll give you one more minute just to finish up that last quadrant. So once you've drawn that, what it should look like is just right here. It should look exactly like what you see there. You can label these points if you want, not going to make you, but this is a really good example to come back to just investigate. In case you're ever unsure, you can come back to this, and specifically this rule. Now, the one key thing here though is clockwise, right? Sometimes you're going to get asked to do it counterclockwise, or they're not going to tell you anything, because technically how mathematicians have numbered this thing is how you see here. If it wants you to go from the first quadrant that's the one we're used to working in, to the second quadrant, as it's labeled here, that's not clockwise. That's either a 90-degree turn counterclockwise, or it's a 270-degree turn clockwise. So you have to really think about how you're supposed to set it up before you instantly just start, oh, this is what I think it's going to be. Because the coordinate plane goes counterclockwise, but this rule exists clockwise. So whenever you're thinking about it and you're unsure what to do, just think about how you would rotate that clockwise, okay? So and if you're ever unsure about which quadrant, this is where you can find this. So a lot of your information for reflection is going to come on page 230. I know it's normally at the start of a unit chapter. That's not the case in this one. And same thing, they give the full explanations down here of how this stuff's done. What we're going to do now is we're just going to take our break. We'll do it 5 minutes early. So we'll come back at 2:10 just so we don't have to break halfway through the next stuff here. So take a break here. And we'll come back in 15 minutes. Okay?